Today we start with definite integrals. So definite integral by definition is the integral a to b f of x dx. Now a is called the lower limit, b is called the upper limit, f of x is the function to be integrated. Now a and b need not be constants, always it can be functions also, and it is always read as from lower limit to upper limit. Now integral a to b f of x dx actually gives the area of the curve f of x between the limits a to b. Now when you integrate f of x, if you get it as capital F of x, then the upper limit is substituted first minus the lower limit. So the function is, the answer is capital F of x. When you substitute upper limit, it will become capital F of b minus lower limit means capital F of a. So we evaluate a definite integral. This is the formula that you are going to use. Directly we start with the properties of definite integrals. Most of the problems and properties based here are more related with the syllabus of engineering students. So first property is integral a to b f of x dx is equal to minus integral b to a f of x dx, which means when I interchange the limits, a negative sign is being introduced. If you want to prove this property, we just go in for the proof. So integral a to b f of x dx by definition is capital F of b minus capital F of a, which can be rewritten as, with a minus sign taken out, you can rewrite it as minus of, in the brackets, capital F of a minus capital F of b, close brackets. Now this minus is kept outside. Now f of a minus f of b can be rewritten in the integral form as integral b to a f of x dx, and that proves the property. Second property is integral a to b f of x dx is equal to integral a to c f of x dx plus integral c to b f of x dx if a is less than c is less than b. That means when c is some point which is introduced between the interval a to b, then you can split it as two integrals and do that integration. We give a proof here. So when we go for the proof, second property, so you start with this right hand side, integral a to c f of x dx plus integral c to b f of x dx is equal to, by definition, capital F of c minus capital F of a for the first integral plus capital F of b minus capital F of c for the second integral. Now this f of c minus f of c gets cancelled, leaving you with f of b minus capital F of a. So this can be rewritten in the integral form as integral a to b f of x dx, and that proves the property. The third property is integral a to b f of x dx is equal to integral a to b f of y dy. Now here we only changed the integrating variable, but the function remains to be the same. So whatever it is, whatever be the variable, for example, if you say you want to integrate x square, you get x cubed by 3. If you want to integrate y square, it's going to be y cubed by 3. So anyway, it is going to be the same after you substitute the limits. And please remember, when the limits are constants, your answer will be the same, whatever be the variable, x variable or y variable, you will get a constant value. So if the limits are constants, your final answer will always be a constant, and whatever be the dummy variable, it does not matter, it will always be the same answer when you integrate. Fourth property is integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx, which means I am changing my variable x to a minus x, where a is the upper limit, provided my lower limit is always 0. Now this property will be used more often in solving the definite integral problems. And to give a proof for this, integral 0 to a f of a minus x dx, we will take again the right hand side. Now you make a substitution, a minus x is equal to t, differentiate it, so you get for a is 0, x is minus dx, and for t it is dt. Now whenever you change the variable, you have to change the limits. So when x is 0, that is a lower limit, you substitute 0 here, you get a minus 0, which is t. Therefore, when x is 0, t is a. And when you substitute your upper limit, x equal to a minus a is going to be 0. So that will give you a limit as 0. So when you change the variable, you have to change your limits. Do not write it with the original limits. So now it becomes integral a to 0 f of t minus dt, because dx is minus dt. Now this you can use the negative sign and change it. So that will give you as integral 0 to a f of x dx. And so this property is very useful, and we will use this for all our problems. Now we come to property number 5, that is integral minus a to a f of x dx, which takes two different values. 2 times integral 0 to a f of x dx is f of x is an even function, and 0 if f of x is an odd function. So to prove this fifth property, we'll have to prove it as two different cases. One case when f of x is even, the other case when f of x is odd. So first integral minus a to a f of x dx. First case we will take f of x is even. F of x is even means f of x is equal to f of minus x. Simple examples are x square. So minus x whole square is again x square, therefore x square is an even function. Similarly, cos of minus x is cos x, so cos x is an even function. So when you take this, now you split this integral minus a to plus a f of x dx as two different integrals, as integral minus a to 0 f of x dx plus integral 0 to a f of x dx. Now, in the first integral, you make a small substitution, that is put x is equal to minus t. Then you get dx is equal to minus dt. So, when x is minus a, you substitute here, you get t is equal to a. And when x is 0, t is also 0. So, the first integral changes as integral a to 0 f of minus t minus dt plus the second integral, which remains the same. Now f of minus t is going to be f of t, since f of x is an even function. Outside there is a minus dt, so that minus sign will change the limits in this integral, changing it as integral 0 to a f of t dt plus integral 0 to a f of x dx. Now they are just x and t are dummy variables, so this can be added to give you as 2 times integral 0 to a f of x dx. Now you come to the second part, when f of x is an odd function. Now then f of x is minus f of minus x, or you write it as f of minus x is equal to minus f of x. Now again you split the integral minus a to f of x dx as integral minus a to 0 f of x dx plus integral 0 to a f of x dx. Now use the same substitution as we used above, x is equal to minus t. Now when you change that, you get it as integral a to 0, limits will change from a to 0, and f of minus t minus dt plus integral 0 to a f of x dx. Now here f of minus t will become minus f of dt, f of t into dt, because f of minus x is equal to minus f of x. So that becomes here minus f of t dt, and this minus sign we will change the limits, as a to 0 will now become 0 to a. So this now reduces to integral 0 to a minus f of t dt plus integral 0 to a f of x dx. Now integration is same limits, that means the inner functions can be added, so it becomes a one integral as integral 0 to a f of x minus f of x, just changing the dummy variable to x, whole thing into dx, and that value is going to be 0, and therefore you get your property as integral minus a to a f of x dx is equal to 2 times integral 0 to a f of x dx for f of x is even, and 0 if f of x is an odd function. Now sixth property we will come, integral 0 to 2a f of x dx is also splitting in a similar way as 2 times integral 0 to a f of x dx if f of 2a minus x is equal to f of x, and 0 if f of 2a minus x is equal to minus f of x. Now you can give a proof like we have done for property 5. You can use a similar fashion, use it as 2a minus x, and you can substitute that as t, etc., and solve it. So I am not giving the proof for this, it's a trial for your case. We'll stop here today and continue with the problems in the next video.